So in this video, we're going to look at how the unit circle can give rise to some different relationships between my sine and my cosine values. For example, if I draw the angle of 30 degrees out, remember we measure our angle up from the x-axis. So if I draw that angle of 30 degrees, it'll look something like this, right? And remember, that's my 30 degrees in there. Now we'll start off with just the sine values, right? So starting off with sine, if I want to measure the sine of 30, remember I just come across to my y-axis, right? And we learned that in the previous video. And I see that I sit here at about 0.5, right? So I see that the sine of 30 degrees is 0.5. Now, what we come to find is there's other angles in the unit circle which can also give 0.5 as well. So for example, what if I draw the angle which comes out here like this, right? Well, if I draw that angle, I also come across to the same sine measurement when I measure across to the y-axis. And it turns out that this would have to be 30 degrees as well. We've got this kind of reflection in the y-axis, right? So in total, the angle that I've gone here would actually be 150 degrees. Okay, so we see that the sine of 150 degrees is also equal to 0.5. And we've generated this relationship that sine has symmetry in the y-axis. Okay, and a mathematical way of writing that, which you might see in some textbooks, right, or written elsewhere, is we say that the sine of my angle theta, right, in this case it's just my 30 degrees, well, that's equal to the sine of 180 minus theta. Okay, so in this case we would be saying that the sine of 30 is the same as, well, 180 minus 30, that's my 150. Okay, so this mathematical kind of writing here is just another way of kind of making this statement that sine has symmetry in my y-axis. So that's a really important property that we want to remember. What about if we look at symmetry in the x-axis? What happens to the sine values there? So let's come down here. So I want to come and reflect this 30 degree angle which I drew up here. And I want to reflect that in my x-axis. So this is now 30 degrees. Well, what happens to my sine measurement? Well, again, nothing changes. I just measure this to my y-axis. And I see I'm now at negative 0.5. So I know that sine of 30 is, of course, just 0.5. And sine of, well, this would be 330 because it's 360 minus 30, right? So this big angle here would actually be 330 degrees. So I'm talking about the one which wraps all the way around to that angle which I drew reflecting my x-axis. Well, this is negative 0.5. And another way of writing this 330, we can actually measure down from the x-axis. So we would measure this angle as minus 30 degrees. So instead of going positively 30, remember positive is to measure up above the x-axis, we can come down below the x-axis and we can measure minus 30 degrees, right? So this is another way of writing sine of 330. It's just to say sine of minus 30. And we know that that's minus 0.5. So what we say is, I like to use the statement sine has negative symmetry. Sine has negative symmetry in the x-axis. So if you reflect an angle in the x-axis, you're going to get the negative version of what you get in the axis your original drawing, right? So if I draw a 30 degree angle and I reflect that into the reflect it by the x-axis, I'm going to get the negative version of whatever I got when I did sine of 30. And that's what we're seeing happen here, right? And a mathematical way that this might be written is we say that the sine of my angle is the negative version of the sine of my negative angle. So in other words, if I reflect that in my x-axis, that kind of gives me my theta versus my minus theta. That's talking about my reflection. And then this minus component is talking about the idea of that negative symmetry that we have. Okay, so you might see that formula kind of written somewhere as well, but don't panic. It's just this statement here, which I kind of prefer. now what we've got to do is we've just got to look at, well, what happens if we look at the cosine values? So I'm going to erase all of this. We'll get rid of all of that there, right? And we're going to do the same thing, but this time we're going to look at the cosine. So if we remove, we'll get rid of all of this. It might be easier if I just kick all of that out. There we go. So what about now if I look at, I'll look at my angle, I'll look at maybe, let's look at 45 degrees. Actually, no, we'll look at 30 degrees again. Let's go back out to 30 degrees. So that's going to be this angle here, right? So remember that angle, 30 degrees. So the same angle, but this time I'm measuring the cosine. So we're going to come down to the x-axis when we measure that. And we end up at about, what's that, 0.85-ish, somewhere around there, right? So we get, say, that the cosine of 30 is 0.85, right? Remember, we can get the exact number in a calculator if we want to, but for the purpose of what we're doing, an estimate's good enough, right? Now, what happens if I reflect this angle in my y-axis, like we did with the sine? What's going to happen there? Well, let's reflect it in my x-axis. So let's come out here, right? And so I've reflected it in my y-axis, and I come down and I measure that value onto my x-axis. Well, here I get negative 0.85, and the angle that I've measured here is just my 150 again. That's my 180 minus my 30, right? So this angle to go all the way around would have to be 150. So I now see that it's kind of an opposite, right? I've now got cosine has negative symmetry in my y-axis. So I get this statement that cosine has negative symmetry in the y-axis. Okay, so it's kind of the opposite of sine. And a way that we can mathematically write this, which again you might see written in some books, is that we say that the cosine of my angle, say my 30, well, that's the negative version of my y-axis reflection. And another way to write that y-axis reflection is the 180 minus theta. That means reflecting in the y-axis. And this negative bit here is just talking about that idea of negative symmetry. Now, what happens if I reflect in the x-axis? Well, let's draw that down to here, right? So this is me reflecting my 30-degree angle in my x-axis. And well, if I measure that cosine value, I have to measure to the x-axis, right? That's how we measure cosine. So we get to the same point which we had to begin with. So we get this idea that cosine is going to have positive symmetry in my x-axis. Again, that's opposite to what happened with sine. So we say that I know that my cosine of 30 is 0.85. Now remember, this angle that I've drawn all the way around to there is actually 330 degrees, or I could look at it as negative 30 degrees. So either of those is fine. So 330, that's the same as looking at negative 30, right? So it doesn't make any difference how you write that. And well, that's going to be 0.85 again, right? And well, what we see is that, as I said before, cosine has symmetry, so positive symmetry in the x-axis. Okay, and a way that we can mathematically write this is that the cosine of theta is equal to the cosine of negative theta. So this is just saying that because I've got a positive here, right? It's the idea of positive symmetry, and this negative theta component is talking about that reflection in the x-axis, right? That's that part here. So hopefully that gives you a little bit of an idea about how there's this idea of symmetry, and we've got this relationship between sine and cosine. And there's a worksheet for you to have a go at some of these yourself, right? And a notes page too.